In section 11.3, we discussed the solubility of different substances in solvents. And in particular, we're going to focus on the solubility of gases because that's a little non-intuitive. So previously, we discussed how dispersion forces give rise to enough solubility of oxygen in water to maintain aquatic life. Now, in gases, the intermolecular forces are quite weak, and this is true for oxygen in water. The dispersion forces that hold the O2 into the water are easily disrupted if the solution gets warmed. As a result, raising the temperature of water radically reduces the concentration of oxygen in water. And this is true for all gases. Raising the temperature of the solvent reduces the concentration of the gas. And the reason being, just like for oxygen, the forces between gas particles are relatively weak. That's why they're a gas. And so raising the temperature easily breaks them. So if these guys are in solution, those forces holding the gas into solution are easily disrupted. So a typical solubility versus temperature chart for a gas looks like just like the one for oxygen. Here we have oxygen concentration in milligrams per liter and temperature in degrees Celsius. And you can see, while it's not linear, there is a negative correlation between increasing temperature and solubility of oxygen. And the reason being, as the temperature rises, the oxygen molecules gain sufficient energy to overcome the weak dispersion forces that are holding them in solution. And the same is true for other gases. Gases are gases because the forces between the particles are relatively weak. So when they are dissolved in a solvent, they have fairly weak forces to that solvent as well. And those forces are easily overcome once the temperature goes up and the kinetic energy of the gas or of the molecules in the solution increases. The solubility of gases is also dependent on the pressure of the gas surrounding the solvent, and this is described by Henry's law, which says that the concentration of the gas in our solvent, concentration of gas in our solvent is equal to a constant, which is called the Henry's law constant, multiplied by the partial pressure of the gas surrounding the solvent. And so what this means is that as the pressure of the gas goes up, the solubility goes up. And this is kind of interesting because when people go diving and they go down, the pressure increases and the solubility of gases in their blood increases, and you can dissolve a lot more gas in your blood when you are under pressure. Now, when you rise up and the pressure is released, then the solubility of gases decreases, and you can actually get bubbles of gas in your blood. It's called the bends or decompression sickness, and it's really, really painful. So divers experience this, and they have to account for it when they increase their pressure by diving deep in the ocean. Of course, the opposite is true. If you travel high into the mountains, you might get a little bit of altitude sickness and start feeling weak, and that's because the surrounding pressure has decreased, and the oxygen levels in your blood as a result will decrease. So if you give it a little bit of time, what will happen is your body will make more hemoglobin so that it can solubilize more oxygen, and you'll feel healthy and strong again, but that does take a little period of acclimation. The alternative is that you can artificially increase the concentration of oxygen, and then that way your blood can solubilize more oxygen. Okay, so that concludes the video on section 11.3.